There are a lot of cheap power meters you can get, but the problems with them is this one, you know, the GT powers, the Turn-G, these 60 volt 100 amp meters. I would never use them at 100 amps, but other than for a few milliseconds. But you know, I prefer these. They have a lot of features that are nice. These are a lot more pretty. These go up to 100 volts. But if you have a couple panels in series, you can easily exceed this one or this one. If you got 3 panels in series, you're up 120, 130 volts. You know, you'll have to go to something way more expensive, and maybe you have these already. So this is a little method you can use to use your existing meters at higher voltage. Basically, it's an amplified voltage divider. It uses one transistor to amplify this voltage divider that's here. We do a 10 to 1, and we have a little kludge. You know, between the base and the emitter, there's a 0.6 of a volt, and we basically put a diode here. Using, you know, if you got one transistor that you pulled out of something, you'll have a second one. And with diodes, you never quite know what the forward voltage is. So just using a transistor is pretty easy. And so this raises the voltage divider by about the offset of this transistor. And it's a little bit of a kludge, but it works. I always say there's the right way, the wrong way, and the Chinese way. And you got to respect the economy of parts in some of these designs that they have. So here's your meter. You'll attach it right here. You got a little filter capacitor, or a little resistor, just to guarantee you're always pulling some current. And you're doing some major voltage drop in these two 3.9K 1 watt resistors, and that keeps the transistor from overheating. But it's fairly simple. This resistor is between 6 and say 8K and 9K. It'll vary with this transistor, but you just see what the voltage coming in divided by 10, and that's what you should see getting out of here. So right now we have it set for 120 volts. This is the input voltage, and it's reading 120.1. I'll go up to the maximum. That's 152.1 on my power supply. This one reads 15.27. That's pretty close. And we'll go down to around 80 volts. So this is 81.2, and this reads out a little bit lower, 80.7. It's still within 1%. You know, it's close enough for all your calculations that you need. And it's a fairly simple method. So when you get any of the readings here, you multiply the volts by 10, and watts will be multiplied by 10 in the same fashion. So it's fairly easy to use, and it allows you to use some of these cheaper meters. And there's the circuit again. These zeners, you want something between 24 and 30 volts, and use 2 zeners in series. That'll keep them cool. The voltage dropping resistors, keep this down around 30 volts. And you just connect up your power meter. A little capacitance here, a little resistance, just to place a load on it and some filtering. It's a kludge, but it works, and this can be very useful. So these power meters tend to draw pretty much constant current, so that's why you can actually do it with a simple transistor like that. Ideally, you'd like to have an op amp, but this works just as well, and you're not involved with a lot of more complicated electronics. So I hope you found this interesting, and Hope you do some experimenting.